Okay, multiplying and factoring radicals. What I try to do is factor the inside under the square root part to something that is a perfect square. It makes it easier. Although you will still get the same answer if you did it another way. I try to use my proper tool. Try to use my multiplication factors. Okay, so the square root of 50 is the same thing as this, and you break down what is inside the radical sign or the radicand is 5 times 10. You break it down until you can't break it down anymore. Or 5 times, instead of 10, I can write 5 times 2. And since there's no root index, no little number out here, it's automatically a 2, which means I need 2 of them, a pair, before it can come out of the square root sign. So here I have a pair of 5s, which will come outside the square root sign. The 2 is left inside, and I have 5 square root of 2, which I can check. 5 times 5 is 25, times 2 equals this 50 that I started with way over there. Okay, the square root of 200 now I can do 25 times 8, but I could also do 100 times 2. Because 100 is a perfect square. And I would have 10 times 10. That's what 100 is, 10 times 10 times the 2, which gives me a pair of 10s. 10 root 2. And I can check that by doing 10 times 10, which is 100, times a 2, which is a 200 that I started with. (81) z to the 4th. 81 is already a perfect square, which is 9 times 9. And I will just write out 4 z's since it's not too many. There's no root index, so it's automatically a 2. And I'm going to circle the pairs, the things I have 2 of. I have 2 9s. I have 2 z's. I have another 2 z's. Nothing is left under the radical sign. So everyone's out, everyone's free. A 9, z, and then another z, which when you combine them is 9z squared. (45) x to the 7th, y 12, z 5. So I'm going to write that in terms of a perfect square, which for 45, I can do 9 times 5. And 9 is 3 times 3 times 5. 7 x's. 12 y's. And 5 z's. I'm going to circle pairs. And I'll underline what's left over and what stays under the radical sign. Can I write that here? Yes, I can. Awesome. Okay, so 3 times 3, that's a pair. 5 left over. Pair of x's. Pair of x's. Pair of x's. 1 x left over. Pair of y's. Y's. Another pair. Another pair. Out of pairs. Okay, no y's left over. Okay, so who is still in the square root sign? We have, ooh, I like how this looks like great. 5x z, still in the square root sign. And outside the square root sign, we have 3. And 3. 3 takes care of that. X, 3 sets of x's. So x cubed. 1, 2, 3, 4, 5, 6 y's. And 2 z's, so z squared. And what you'll notice, hopefully, is that I had 12 y's, which is an even number. So when I do the square root of it, sorry for that, I just cut my exponents in half. For the z's, I had 7. 1 less than that gives me my even number, so I'll cut that in half, and then I still had that x left over here. All right, so the z's, I had 5, 2 plus 2, and 1 left over. This is my final answer for that. Cube root of x cubed y6. So this tells me, my root index tells me how many I need in the group before they can come out. So I have the cube root of 8, and 8 is 4 times 2. 4 times 2, or instead of 4, I can just write 2 times 2. So I can write 2 times 2 times 2 instead of the 8. 2 times 2 times 2, which gives me 8. I have 3 x's and 6 y's. I need 3 of them before I can come out, because I have the cube root now. Everyone's out. So I just have 2 x y squared because I have 2 groups of 3. Fourth root of 162, x to the 5th, y cubed, z to the 8th. I'm going to break down 162 to all the prime components, which is 81 times 2. Instead of 81, I can write 9 times 9. And instead of 9, I can write 3 times 3. So I can write 3 times 3 times 3 times 3 times 2. 4 3s. And I have 5 x's. 3 y's. And 8 z's. Okay, I'm gonna circle my groups of 4 because my root index is 4. So I need 4 before they can come out. There's 4 3s. 6. We have 3 y's. Everyone's gonna stay in there. Okay, so inside my radical, I have 2xy cubed. And outside I have 3xz squared. Cube root of 16 a to the 7th b6 c, so b8 c6. So 16 is 4 times 4, which is 2 times 2 times 2 times 2. 4 2s. 2 times 2 is 4 times another 2, 8 times another 2 gives me 16. 7 A's. 8 B's. And 6 C's. So I'm looking for groups of 3 because my root index is 3. It tells me I need groups of 3 before I can come out of the radical sign. Okay, left inside I have 2ab squared. 2ab squared. It's the cube root. And outside I have 2a squared. I have 2 groups of 3. B squared. C squared. There is so much stuff. Okay. When you multiply, it's going to be the same basic premise. You want to multiply, keep your square root sign, and then whatever pairs you have or whatever the index is that you're multiplying with, you can then take them out. So I multiply first, I multiply first, I multiply first, and then I simplify. But you can do it either way, you still get the same answer. So square root of 8 times square root of 12, 8 times 12 is the square root of 96. And I know that this 96 equals 8 times 12 because I just had that. Instead of 8, I can write 2 times 2 times 2. And instead of 12, I can write 4 times 3. Instead of the 4, I can write 2 times 2. And now I'm gonna, since there's no root index, it's a 2 automatically. And I'm gonna circle groups of 2. And I'm left with not 23, I'm left with 2 times 3. So outside I have 2 times 2, which is 4. Square root of 6. And I can check that. 4 times 4 is 16. And 16 times 6 is 96. Same thing I started with. You can also simplify before you multiply. And you get the same answer. Square root of 10 is the same thing as the square root of 5 times 2. Square root of 45 is the same thing as 5 times 9. And instead of 9, I can write 3 times 3. And when I multiply those together, you get a long square root with all of the things inside. 5 times 2 times 5 times 3 times 3. Looking for pairs, since I don't have another root index specified. I have a pair of 5s and a pair of 3s, and the 2 is left inside. It's not a nice color on the green. So inside I have just the 2. And outside I have 5 times 3, which is 15. So my answer is 15 root 2, which I can check. 15 times 15 is 225. And 225 times 2 is 450, which is the same as 45 times 10. Okay, let's do this one. Fourth root of 27x to the 5th times the fourth root of 15 x cubed y to the 5th. So the fourth root of all of this times all of this. 27, I'm gonna put 9 times 3. And for 15, I'm gonna put 3 times 5. That takes care of the number parts. For the letters, I have x to the 5th times x cubed, that's gonna be x to the 8th. When you multiply exponents, you add them. Y times y to the 5th, it's gonna be y to the 6th. And then let's try to simplify that even more. My new thing gonna be a little black background. The white feels like chalk. Okay, so I'm gonna write this again. Instead of 9, I'm gonna write 3 times 3. Then I have those other 3's. And the 5, x to the 8, y to the 6. And I need groups of 4. So this is 4 3's here. 5 is left inside. This is 8 x's. So I have 2 groups of 4. Right, I really have this. And for the y's, I have 1 group of 4 and 2 left over. So inside I have 5 y squared, 4th root. And outside I have 3 x squared y. And this one on your own when you get a chance, but it's kind of the same thing. Okay, now this one is 2 over 5 is my root index. No, 2/5 times the 50 square root of x. So 2/5 is outside. Square root of 50x, I'll do 25 times 2 and the x. 75, I'll do 25 times 3. And then I have 7 x's. So I have no root index, so it's automatically a 2. I'm looking for pairs. Here is 125, another 25. One set of x, another, a third set, and a 4th set. Left inside is my 6. Inside I have 2 times 3. And outside I have the 2/5 times 25 x squared cubed to the 4th. 25 x to the 4th. So I'll multiply that out. 2 over 5 times 25 x to the 4th over 1. And that'll be multiplied by my square root of 6. This is the way I do it. I don't think I do it the same way. 5 will go into 25 5 times. 2 times 5 is 10 x to the 4th times the square root of 6. Come back and do the rest. Or you can try them, and then if you have questions, holla.